Hello everyone. Today let's see a problem, how to design a valet parking system. This belongs to software system design. Let's see the question. Design a system that will automate valet parking service. A parking garage has a fixed number of spaces. The spaces have three sizes: small, medium, and large. There are also only three car sizes: small, medium, and large. Smaller cars can park in larger spaces, but not vice versa. The system needs to decide where to park a car entering the garage, track space availability, issue tickets to identify where a vehicle is parked. You can pause the video and think about how to solve this problem. For any systems, it contains three factors: elements, interconnections, and the purpose. If we map into the object-oriented design, elements can be mapped to objects and attributes. Interconnections can be mapped to attributes between the two objects, and the purpose can be mapped to the functions. Step 1. Let's identify objects. From the problem description, we can identify those elements easily. We can see that parking garage and the spaces and the car and the tickets. So we can use objects to represent them. We use garage, parking space, car, and tickets to represent those elements. Step 2. Identify attributes. We can open our mind to think about that possible attributes for this problem. For the parking space, we can identify there should be a space number, and also it should need to have a space size of it. For car, it should have a plate number to identify each car, and also have a car size. For the ticket, we need to print out plate number and maybe enter time and also space number. Those are static attributes for those objects. Step 3. Identify object relations. For the garage, we can identify it must have parking spaces. For this problem, we have three different sizes of parking places. So for the garage, we can have three lists to store them. When a car is occupied one parking space, for the garage, we can have a hash map to map to the tickets. For the parking space, we should have attributes to identify that parked car, and we will store the car objects there. Step 4. Identify functions. For this problem, we can identify two functions. For the garage, we have a park function. When a car enters, we call that park function, and it will return a ticket. Another function is when a customer goes to the garage and retrieve the car, they will present a ticket and to get the car back. So the second function is retrieve function. For a successful design, we need to consider several choices. In this problem, we need to consider hash map, because in the garage we use a hash map to store all the parked cars. The hash map, the time complexity is O1 because in its implementation we usually use an array and use a function, hash function, to convert keys into a value to map onto the array bucket ID. So putting and retrieve and search, the complexity is O1 for that array. But sometimes two keys may map to the same buckets, so it has a hash collision. For the worst case, hash collision, the complexity would be On, because in a bucket, all the entries are use the linked list to store all the data. So in the worst case, we need to look every elements in the linked list. So the worst complexity will be On. But for JDK8, it uses balanced tree to implement the hash collision case. So the complexity will be log n. Another design choices will be for function. Should we return error code or exception? It depends on the situation. If in the real world its meaning is an exception, so we can use the exception. Otherwise, we may use error code. Another design option is if this system needs to support multi-threading, like there are several valet managers help you to park the car, so they may operate at the same time. We need to consider those cases. Maybe for simple, only for the function we use synchronized to decorate. That's enough. Another design choices is high availability. If this system needs to be active for all the time, we need to consider high availability. As first, we need to use load balancer to distribute the traffic to the different hosts, and on each host run the business layer, and we also need to use the centralized persistence layer. And maybe for such a service, we need one subsystem to be the persistence layer, and we also call it a storage authority. For example, we may use MySQL to be the storage, so we can use master-slave mode to run the MySQL to make sure it has a high availability. That's all for today's topic. Thank you.